Hi. So the final topic we are going to cover today is ARIMA model. As the title of this video suggests, ARIMA models are frequently used for time series forecasting. So before we discuss this model in detail, let us first figure out what ARIMA stands for. So AR means autoregressive. As discussed in the beginning of this lecture, autoregressive process is when value of variable depends on its own lagged values. I stands for integrated. So ARIMA is estimated based on stationary data, and in order to ensure stationarity, we perform first differencing. And order of integration will stand for the number of first differencing procedures which is needed in order to make sure that data is stationary. And MA stands for moving average. So in this case, the dependent variable depends on the lagged error term values. So altogether, ARIMA model means that the value of the variable can be described as the linear combination of its own lagged values and lagged error terms. In the very general form, ARIMA can be described using three indicators, P, D, and Q, where P stands for the number of autoregressive terms, like the number of lagged values to include to the model. D stands for the number of non-seasonal differences or the order of integration, and Q stands for the number of lagged error terms to be included to the regression model. So we can analyze several cases for ARIMA depending on the values of P, D, and Q. So ARIMA of 100 is just first order autoregressive model. So in this case, we do not specify any error terms, lagged error terms. MA is equal to 0. We do not perform any differencing. We just assume that the value of variable depends on its own value in the previous period. ARIMA of 010 is basically for modeling random walk series. In this case, we do not include any autoregressive terms and no lagged error terms, and we do first order differencing. Differencing for the first order of integration. ARIMA of 110 is basically differenced first order autoregressive model. So in this case, we estimate autoregressive model not for variables in levels, but for the first differences of these variables. ARIMA of 011, no autoregressive terms. You perform differencing procedure one time, and you include one lagged error term to the model. Is basically about exponential smoothing, and ARIMA of 012 is about linear exponential smoothing. Okay, so actually specification of ARIMA might be other way around. So you can decide on the specification of ARIMA based off analysis of parallelogram. I will show you. So in our case, we will use Tesla dataset, and because this variable is very likely to have a unit root, like almost 100% certainty, yes it does, it makes more sense to analyze not prices of stock but returns, like percentage change of the value of stock. So we will calculate this value. We call it Tesla daily returns. Okay, and here we are. Okay, we can double check, but usually for daily frequency data one time differencing is more than enough. Okay, yes. So finally, we have a stationary data set. So in order to calculate parallelogram, you have to click variable, then parallelogram. Okay, actually this number of flags was selected automatically. Let's stick to it. Okay, and this is the graph we're interested in. So ACF stands for autocorrelation function of residuals, and PACF stands for partial autocorrelation function of residuals. So those blue lines are the boundaries. So if the values of correlations go beyond those boundaries, then actually some correlation is present. But in our case, this is actually not the case. So it even does not look like we might, include any lagged error terms. But still, let us do it just for demonstration purposes. So you shall click Model, Univariate Time Series, ARIMA. Tesla daily returns is the dependent variable, of course. In this case, we will not do any further differencing because the dataset is stationary already. And let us just specify one autoregressive term and one lagged error term. So here we are. Okay, so as I told you, typically ARIMA model is used for forecast. This is how you do this. You have to click Forecast. And in my case, I did not specify any sample because typically, for instance, today is the 19th of August. So typically I would stop at the end of July and then see whether prediction of model for the first half of August coincides with what happened in the first half of August. But in this case, we did not do this. So here the new time range is created automatically. So this is the end date in observations. We do not have further values, and here we have predicted values. So as you can see, okay, confidence intervals are huge, definitely. So I wouldn't definitely invest based on the output of this model. But again, it was done for demonstration purposes. It was not assumed to be good. So we might try a bit different specification, like let us edit, modify model. So in this case, I will assume one autoregressive term, and I will not specify any lagged error term values. So here we are, and let us try to do the same forecast again. Okay. No, they are still huge. Okay, nevertheless, so that was it when it comes to ARIMA model. Unfortunately, when it comes to time series analysis, it's a lot about art, and natural predisposition to analyze the trends. And unfortunately, there is no good recipe for specifying proper ARIMA model. Like you can only use parallelogram, and you can only analyze properties of your time series. So that was it. I thank you for your attention. And actually, this is the end of this course. So I really hope you enjoyed it, and I would be very grateful if you find some time to send me a short feedback note. Thank you.